Hello and welcome to Module 3 in the QGIS video tutorial course. In this module we're going to be looking at classifying vector data. Classifying vector data allows you to assign different symbols to features depending on their attributes. This allows someone who uses the map to easily see the attributes of various features. So let's start by looking at attribute data. Up to now, none of the changes we have made to the map have been influenced by the objects that are being shown. In other words, all the farms look alike and all the roads look alike. When we're looking at the map, the viewers don't know anything about the roads they are seeing, only that there is a road of a certain shape in a certain area. But the whole strength of GIS is that all objects that are visible on the map also have attributes. Maps in a GIS aren't just pictures. They represent not only objects and locations, but also information about those objects. The goal of this first section is to explore the attribute data of an object and understand what the various data can be used for. So let's go ahead and take a look at some attributes. I'm going to open the places layer that we looked at in the previous tutorial. And by right-clicking on places and pressing open the open attribute table, we can see the attributes that are contained for each feature within that layer. If we were going to use one of these attributes as a label on the map, the most useful one would be the name column. So now you know how to use the attribute table and to see what's actually in the data that you're using. Any data set will only be useful to you if it has attributes that you care about. If you know which attributes you need, you can quickly decide if you're able to use a given data set or if you need to look for another one that has the required attribute data. Different attributes are useful for different purposes. Some of them can be represented directly as text for the map user to see. You'll learn how to do this in the next section. The label tool. Labels can be added to a map to show any information about an object. Any vector layer can have labels associated with it. These labels rely on the attribute data of a layer for their current content. The goal for this section is to apply useful and good-looking labels to a layer. Before being able to access the label tool, we're going to need to ensure that it's been activated. We can do that by going to View, Toolbars, and clicking the Label checkbox. We can see now that the Label toolbar has been activated. Let's go ahead and open up the label panel. To activate labels for this layer, we have to go ahead and check the Label this layer with checkbox, and then we can choose one of the columns from the attribute table. I'm going to choose the column Name. If we now go ahead and press OK, we'll see the labels added to the map. So now we've got our labels displaying, but as you can see there's a few problems. Some of the labels aren't very easy to read above the data that's below them, and also some of the labels are overlapping the point slightly. So let's go ahead and fix those problems. By right-clicking on Places and going to Properties, we can select labels from this menu, or alternatively, like before, we can use the Label button up in the top menu. So I'm going to change the font size up to 10, and also I'm going to add a buffer. A buffer will add a halo around the text that will make it more easy to see above the data below. So let's add the halo and change the font size and see how it looks. As you can see now, the labels are much larger and they're very easy to read above the data below. Next, let's fix the problem of the labels overlapping the points. Let's press the Label button again, and from in here, when we go to the plate, we can press Placement in the left-hand menu here, and we have one option called Distance. Let's set the distance to 2 and press OK. We can now see that the labels have been offset above and to the right of their respective points, using labels instead of layer symbology. In many cases, the location of the point doesn't need to be very specific. For example, most of the points in the Places layer refer to an entire town or suburb, and the specific point associated with that feature is not that specific on a large scale. In fact, giving a point that is too specific is often confusing for some users who are reading the map. To name an example, on a map of the world, the point given for the European Union may be somewhere in Poland, for instance. To someone reading the map, seeing the point labelled European Union in Poland, it may seem that the capital of the European Union is therefore in Poland. So to prevent this kind of misunderstanding, it's often useful to deactivate the point symbols and replace them completely with labels. In QGIS, you can do this by changing the position of the labels to be rendered directly over the points they refer to. To do this, we once again open up the Label Settings dialog, and also within the Placement setting, we'll see one option called placement, and we're going to change it from around point to offset from point. If we now press OK, we'll see that the labels have now been centered on the point. We also want to hide the underlying point. So I'm going to right click on the point settings, open up the properties, and in style, I'm going to set the size to 0. Labeling lines. Now that you know how labeling works, there's an additional problem. Points and polygons are easy to label, but what about lines? Let's go ahead and disable the places layer that we were working with before, and let's enable labeling for the roads layer. Like before with the places, we can now see the labels, but they're not very clear or easy to read. So let's go ahead and make a few changes. I'm going to start by reducing the size of the font and changing the font type to Arial again. So let's go to Arial and let's reduce the size to 7. And we'll also add a buffer so we can easily read the labels above the data below. So we press OK now. And as you can see, the labels are now over the streets and they're easy to read. But also you might notice that some of the labels are quite cluttered, and often the labels aren't following the streets, and some of the labels are repeated. So let's go back into the layer settings again, and from here we're going to go back into the placement settings, and from here we're going to change the position from above line to on line. If we press OK, we'll see that now all of the labels have been positioned above the line that they represent rather than above them. So now it's better than before, but it's still not ideal. For starters, some of the names appear more than once, and that's not always necessary. To prevent that from happening, we can enable the option Merge Connected Lines to avoid duplicate labels. We can see that option by clicking on the label settings, going to rendering, and if we scroll down, we'll see the option here, Merge Connected Lines to avoid duplicate labels. I'm also going to change the option here, Suppress Labeling of Features Smaller, and I'm going to set that to 5 millimeters. What this will do is this will increase the gap between each of the labels to avoid collision. Now we can see that the labels are no longer repeating, and we also have fewer labels on the map because of the 5 millimeter setting. The one last change that I'm going to make to these labels, if we go back into the layer settings again, I'm going to go to the placement options, and I'm going to change the placement from parallel to curved. If we press OK, we'll see that the result is now that the labels will actually follow the curve of the streets. So now our labels are finished, and as you can see, this hides a lot of the labels that were previously visible because of the difficulty of making some of them follow the twisting street lines and still be legible. You can decide which of these options to use depending on what you think seems more useful or what looks better. Further possibilities with labeling. We can't cover every option in this course, but be aware that the label tool has many other useful functions. You can set scale-based rendering, alter the rendering priority for labels in a layer, and set every label option using layer attributes. You can even set the rotation, XY position, and other properties of the label, if you have attribute fields allocated for that purpose. Then edit these properties using the tools adjacent to the main label tool. These tools will be active if the required attribute fields exist and you're in edit mode. Feel free to explore the possibilities of the labeling system. Now that you've learned how to use layer attributes to create dynamic labels, this can make your map a lot more informative and stylish. So what's next? Now that you know how attributes can make a visual difference to your map, how about using them to change the symbology of objects themselves? That's the topic of the next part of this. Delete that last part. So what's next? Now that you know how attributes can make a visual difference to your map, how about using them to change the symbology of objects themselves? That's the topic of the next lesson. Classification. Labels are a good way to communicate information, such as the names of individual places, but they can't be used for everything. For example, let's say that someone wants to know which area the farms are in. Using labels, you'd get this. Obviously, this isn't ideal, so we need another solution. That's what this lesson's about. The goal for this lesson is to learn how to classify vector data effectively. Classifying nominal data. So instead of using the labels, we're going to use a category legend. So I'm going to go back and I'm going to turn off the labels that we're using here on the rural layer. And instead, I'm going to right click on the rural layer. I'm going to open up the properties, and from the drop down here, I'm going to select categorized. Now in the column, I'm going to select which property I want to use the categories with, and I'm going to select town. And we have a choice of color ramps here. I'm going to use the default setting, which is random colors, and I'm going to press the classify button. You'll see that each of the different values inside the attribute table has now been assigned a color. And if we press OK, we can now see that each of the areas has been given a color in the map, and in the legend on the side here we can see what each of those colors represent. So now we have a category legend. Let's go ahead and make a few changes. I'm going to zoom out just so we can have a look at the colors that we have here. If we want to change the colors, we can go back into the properties section and we can press the delete all button, and if we choose random colors again and press classify, we'll be given a new set of colors, and we can repeat this process until we see a set of colors that we're happy with. Okay, I'm going to go with these colors here. And also on the map you'll see that the outlines have come back around each of the farms. We can remove the outline by clicking on the change symbol button here, and just as we did when we were doing single symbol legends, we can change the border style from solid line to no pen. So let's press OK. Let's quit out of that and see what we have. As you can see now, the borders around each of the farms have been removed, but I'm still not completely happy with the colors. So what we could do if we wanted to change the colors to our own choices, we can just come back into the settings section for the categorized legend, and we can click on each of the individual colors in the legend, and then we're able to assign our own colors for each of the items that it contains. What we can also see here is we have an empty category at the bottom here. An empty category is where there are rows inside the attribute table for the town column that don't have a text value in them. We can remove that category just by clicking on it from the list here and pressing the delete key, and then any empty features that don't have any value within that column will be removed. And removing that item from the legend doesn't actually remove it from the underlying data set, so don't worry about whether this setting will be modifying your underlying data, because it isn't. Ratio classification. There are 4 types of classification: nominal, ordinal, interval, and ratio. In nominal classification, the categories that objects are classified into are name-based. They have no order. For example, town names, district codes, etc. In ordinal classification, the categories are arranged in a certain order. For example, world cities are given a rank depending on their importance for world trade, travel, or culture, etc. In interval classification, the numbers are on a scale with positive, negative, and 0 values. For example, height above and below sea level, temperature above and below freezing, 0 degrees Celsius, etc. In ratio classification, the numbers are on a scale with only positive and 0 values. For example, temperature above absolute 0, distance from a point, the average amount of traffic on a given street per month, etc. In the example above, we use nominal classification to assign each farm to the town that it's administered by. Now we'll use ratio classification to classify the farms by area. So we want to classify the farms by area, but there's one problem. They don't have an area field, so we're going to have to add one. So let's open up the attribute table on the rural layer, and we're going to press the edit button, which looks like a pencil up here, and then we're going to press the new column button. So let's create a new column. Let's call it area, and we're going to make it a decimal number. So we click OK, and now if we go to the end, we'll see that we've added the area column, and each of the records inside of this particular layer has a value of null. To solve this problem, we'll need to use the field calculator. From within the field calculator, expand the geometry property and double click on area. And at the top here, we've got a choice between create a new field and update an existing field. We're going to update the field that we just created, which was area. And now if we press OK, we'll see that now our area column has been populated with values. Now that we have our populated area column, let's go ahead and close the attribute table, and we're going to and we'll also turn off the edit mode. When we turn off edit mode, it'll ask us to save the layer. So I'll press save to save that new column. And let's go ahead and update the styling. So we open up the property box like normal, and from the drop down here, we're now going to choose graduated colors. So as before with the categories, we have a column drop down. From here we'll choose the area column, and as you can see we've been given 5 default values. Like before, we get to choose from a color ramp, and I'm going to use a new color ramp for this particular legend, and please select the color ramp type. We'll go with gradient, and then in here we can select 2 colors. So I'm going to go from a yellow through to an orange. As we can see, our new color ramp has now been created. If we press OK, and let's zoom out so we can see the changes, we can see that the new color ramp has been applied to the rural layer inside our map. Like before, let's go in and let's get rid of the lines between each of the individual farms. As with the category legend, we just press the change button, and in here I'm going to change the border style to no pen. Now, some other settings that you can play around with in here are the number of classes and the mode. The number of classes is the number of items that we'll see inside the legend, so we could change that to 6. We'll move it back to 5, and the next one is mode. Mode is the algorithm that's used to classify the different class breaks in the legend. So by default it's set to equal interval. Let's see what happens if we set it to quantile. Press OK. You'll see that we have far more even separation of the different colors in the legend. I'm going to go back again and we'll try one more mode. We'll try standard deviation. Let's press apply and see how it looks. There we are. Rule-based classification. It's often useful to combine multiple criteria for a classification, but unfortunately normal classification only takes one attribute into account. That's where rule-based classifications come in handy. Let's go back into the rural layer and select on properties. And from the drop-down, we're now going to choose rule-based categorization. So by default, there's one rule inside of here. I'm going to remove the default rule, and now we need to start building rules for our classification. We can add a new rule by pressing the plus button at the bottom. I'm going to add 3 rules. I'm going to call this one not in Swellendam, and I'm going to apply a filter now. If we press on the button here, and the filter for this one, I'm going to go to the field and values. I'm going to choose municipality. Doesn't equal, and then I can load all of the unique values here, and I'm going to choose Barrydale and Swellendam and press OK. So there's my first part of my first rule, and I can set the color for this rule down here. I'm going to make all of the places that aren't in our area of interest dark grey. Press OK, and we now have our first rule. And for the second rule, I want to see all of the farms that are smaller. Actually, that's usually less than farms. Less than or equal to 0.0085, and we'll add another filter here. So we say field of values, the area, then from operators, less than or equal to, and then the value 0.0085. Press OK, and let's change the color again. I'm going to make the farms, the smaller farms, a light yellow. Press OK, and we now have a second rule, and I'm going to add a third rule. Farms bigger than or equal to 0.0085. Let's build the rule again. So we say field and values, choose the area, then from operators, greater than or equal to, and we'll put the value of 0.0085 again. Press OK. You'll also notice that there's a test button here. When we're building the rules, we can press the test button and we can see how many features in our data set match this rule. So in this case, we have 173. So let's press OK. And now when we press OK at the bottom here, those rules will now be applied to the map. Now you may have noticed one problem with the map currently. We should only be seeing farms as green and yellow that are actually in Swellendam. But we can see here that farms that aren't in Swellendam have also been coloured. And this is because of the drawing order. If we go back into properties, in the bottom right corner here we have a rendering order button. Now what we need to do is we need to make sure that the not in Swellendam layer is rendered on top. So we'll put that to number 2 in the layer order. We'll put the farms to number 1, and we'll put the farms that are bigger than 0.00085 at the bottom. If I press OK and now press apply, we'll see now that all of the farms that aren't in Swellendam have now been given the grey colour in the legend. In conclusion, symbology allows us to represent the attributes of a layer in an easy to read way. It allows us, as well as the map reader, to understand the significance of features using any relevant attributes that we choose. Depending on the problems you face, you'll apply different classification techniques to solve them. So what's next? Now that we have a nice looking map, and we're going to get it out of QGIS into a format that we can print out or make into an image or a PDF, and that will be the topic of our next lesson.